All right, here's another example where you are working backwards to find a particular sample size. So in this case, it says if the true proportion equals 0.7, how many people should be sampled to be 90% confident that an estimate is within 0.05 of our true proportion? So 0.05 is our margin of error, and we basically want our margin of error to be less than or equal to 0.05. Well, we calculate our margin of error by doing z star times the square root of p hat times 1 minus p hat over n. So for a 90% confidence level, I'm going to use my t-table 90%. We're using 1.645. So it's going to be 1.645 times the square root. They give us 0.7, we're going to use that for p hat, so 0.7 times 1 minus 0.7 over n. So we're going to work backwards to figure this out. So the video kind of does it in a little bit of a funny way, but I'm going to kind of walk you through it here. First thing we need to do to get n by itself is we are going to divide by 1.645. And I'm going to write it kind of like that. So it kind of looks like a fraction. And then what he does is he says that we can actually rewrite 0.05 as 5 over 100, just so it kind of looks like a fraction as well. And then what we're going to do is these cancel out, so we're left with 0.7 times 1 minus 0.7, which is 0.3. That's 0.21 over n. And then here, we're basically going to multiply 5 over 100 times 1 over 1.645. Well, the top becomes 5, and the bottom, we multiply this by 100. It just moves a decimal over 2 places, so 164.5. All we are doing here is a little bit of algebra. And then he actually writes this as kind of separating out the square root, kind of breaking it up. And then what he does is he takes the reciprocal, he flips these around to get n in the numerator, which is what you need in order to solve. So then you're left with the square root of n over the square root of 0.21. And when you flip, you take the reciprocal, the inequality symbol also has to change. You have 164.5 over 5. And then what we're going to do is we are going to divide this out, which equals 33.1. So then what we have here is the square root of n over the square root of 0.21 is greater than or equal to 33.1. And then we're going to multiply both sides by 0.21, or square root of 0.21. So we're left with the square root of n is greater than or equal to, so 33.1 times the square root of 0.21 is about 15.168. And then lastly, to get rid of that exponent, we're going to square both sides. So we get n is greater than or equal to 230.07. And for sample size, we're always going to round up, which means we need a sample of 231. So this seems really complicated because it kind of is with the algebra. I would not worry too much about this. What you can do is, what the problems that I'm going to give you, you're really just going to be able to plug in the answer. So I'm going to show an example of that. But really all we're doing here, even though it seems complicated, is just a lot of algebra. Okay. So let me show you how to do it with a multiple choice. So this one is significantly easier to do it with a multiple choice problem. It says Angela wants to use a one sample z interval. We're doing a 90% confidence level. So that means we're going to use a z star of 1.645, just like the previous one. And we want our margin of error to be less than or equal to 0.05. All right, so to figure this out, we're just going to try and plug in different numbers. So our margin of error, we calculate that by doing z star times p hat times 1 minus p hat. So if you look at this problem, they don't give you a p or a p hat. Whenever they don't give you a p or p hat, you're going to use p hat of 0.5. Okay, so it's going to be 0.5 times 1 minus 0.5 over n. And we want that to be less than or equal to 0.05. So now I'm going to fill in my z star value here since we know it's 1.645. Oh, and this idea of if you don't know what it is, use 0.5. If that comes up and there's no p hat value or not sure what to do, that's kind of the opportunity where you should ask during a test, and I'll let you know. But generally, I will give you a p hat for these types of problems. All right, so an easier way to do this is to just go ahead and plug in these numbers for n until you get a value that's less than 0.05. So I'm just going to start with the smallest one, 1.645 times the square root. 0.5 times 1 minus 0.5 is actually 0.025 or 0.25. Yeah, 0.25. So 1.645 times the square root of 0.25 over 144. We get about 0.07. So that's not going to work. So that's a little bit too high. So let's increase our sample size. Let's try C. So now let's plug in 271. So we're going to plug in 271 for n and see what we get. So plugging in 271, we get 0.0499. Well, that's just under 0.05, and I don't think we can get any closer than that, which means C is the correct answer choice for this one. So if you're given an open-ended question, yes, you are going to have to do some crazy algebra, but if it's a multiple choice problem, you can actually just plug in these numbers to see which one gives you the margin of error that you want.